Hello and greetings. This is question number 9 of October November 2024, variant 2 of A level math paper. So, this is a question of vectors, and this O is given, OB is given, OC position vectors are given. That means A, B, and C are given. Point D is to be found, position vector. So OD is not given, but we know that DC is 3 times of AB. But since we haven't got AB, we need to find AB first and then multiply with 3 times of AB. So let's find it. AB can be written as OB minus OA. So OB and OA, both the values are given. OB is 0, 4, 1 and OA is 2, 1, negative 3. This would give us AB as minus 2 and 4 minus 1 is 3 and 1 minus minus becomes plus, that would be 4. So 3 times of AB would give us DC. So let's find DC. So 3 times of AB DC would be minus 6, 9 and 12. So that would be DC, that means 3 times of this. Now the problem with this is that we don't need DC. We had to find point D, and D was point DC is equal to OC minus OD. So we need to find OD or D, so OC minus DC. Oh yes, we would have required DC, so that would help us to find DC also. So yes, I believe I made a mistake here. Let's see if I get this right or not. So OC is already given, minus 3, minus 2, 2, and DC we have just found. So OD will be minus 3 minus plus minus minus plus, that would be plus 3, and the other is 2 minus 9, that would be minus 11, and 2 minus 12 will give us minus 10. Yeah, it's correct. That means that was also correct. So OD is this, or we can say that position vector D, we know that this can be written as ijk, so we would have 3i minus 11j minus 10k. That was the part A. In part B, they are saying that the diagonals of the trapezium, so this is a lengthy question. So if you have this trapezium making a rough one. Okay, so if you have, this is AB and this is CD, so we know that AB is 3 times of DC. So the lines, that is diagonals AC and the diagonal BD, these two equations have to be found and to get the position vector P, because they are intersecting at some point where the diagonals are meeting up here. That is point P. So first of all we need to find AC. So AC can be simply written as that AC can be found by OC minus OA, and the values of OC were -3, -2, 2, and this was 2, 1, -3, and the answer for AC would be -5, 3, and 5. So we know that the equation of line is position vector plus lambda of direction vector. So position vector from A, that is starting, this is A, this is this, and direction is this. So we would simply call it the equation R1 as 2, 1, 3 as position vector OA, and added with the lambda in the direction vector, that is starting from A, from here and till C. So this will be the starting point and ending at 3. So this is the direction and this is the position vector A. So we would have as the resultant, whatever it is, 5, and this would simply give us the result of first equation, that will be 2 minus 5 lambda, 1 minus 3 lambda, and the last will be 3 plus, is it 3 or minus 3? It was -3, right? minus 5 lambda. So for equation 2, that is starting from B to D. So again, for the same steps, we would have B to D as OD minus BD. So we have just found the result of OD from the first part, that was this. We'll just plug in this value over here, and the OB was mentioned in the question. So we'll just plug in the values. So OD is simply 3 minus 11 minus 10. OB was 0, 4, 1, and this gives a resultant of 3 minus 0 is just 3, and 11 minus 4 would give us minus 15 and minus 11. So in this we can form equation R2. Simply this is a direction vector, this OB, like starting from B until D. So this is the resultant. So we would simply have this, we can't call it lambda, we can call it mu. So let's start with this 0, 4 and 1, and plus, let's call it mu, and the direction vector is 3 minus 15 and this. So we would have another equation of R2 would be 3 mu 4 minus 15 mu and 1 minus 11 mu. So we have these two equations. So equation 1 and equation 2, we can just get the two rows equated first to have the intersection. So we will say that 2 minus 5y lambda can be equated with 3 mu. So this would give us as, I can shift this over there, 5 lambda, and this would give us minus 2. No, this would be minus. So in order to make it plus, you have to multiply the whole sign and have this would turn out to be 2 minus 3 mu. Okay, the other equation that can be equated is 1 minus, I'll write it here, 1 minus 3 lambda with the second row of the second equation, 4 minus 15 mu, and by this, if we want to get lambda, we need to have 3 lambda on this side minus 3 lambda. So you would have 4 minus 15 mu and the minus 1. So you'll have, like, change the signs. That would be simply lambda would be equal to and I'm just also dividing it. So 15 mu minus, like, first of all dividing my whole side 3. So what can this 3 can cancel this 15 and that would be 3 also to cancel this. So you'll be just having 5 mu minus 1. So we can plug in the value of lambda or in the value of mu, whatever we think. So first, let's say I'll plug in the value of lambda, that is in this equation, 5u minus 1 equals, so you will have 25 mu minus 5 equals to this 3u. So you would have the value of mu as directly 1 by 4, and same can be plugged into this to get the value of lambda, 1 over 4 minus 1, and you have the value of lambda would also be same. It turns out to be same. Yeah. Now we have mu and lambda same, so these can be easily plugged in either equation. Now the equations for point AC intersection is AC was, we know that AC is this was the line. Let me just highlight it for you, this one, or maybe we can just drag this from here and copy it down to get directly plugging in the values. Okay. So either, yeah, we can plug in the value of lambda. So lambda would be 1 over 4, 1 over 4 and 1/4. So you'll get the final answer as, I'm just directly writing the final answer. Instead of R1, I can just write now that it is AC. Okay, let me just take one more baby step. And this would turn out to be negative 5/4. And this would turn out to be negative 3/4, and the last one will be 1/4. This can be simplified as 3/4, 1/4, and the last will be 7/4 negative. So we say that this can be the point of intersection at P, but this can be written as position vectors I plus 1/4 J and negative 7/4 K. So that was it. This was a lengthy question. Part B was a lengthy one. The last part is C, and the C can be given as the product of scalar vectors. So product means this is, let's say, diverging point from B, A and C. So theta is to be calculated, and we already know that OB, we have found the OB, and we have OB, yes, we have OB from the question, and nothing else to be known. BA is also known, so we'll just apply the formula. Do we have it? Let me just double check it. We have OB, OA, so but we don't have BA or AB. We haven't found, yeah, we have. So AB was this. This is already have AB, and AB times of BC. Do we have BC? Did we find BC earlier? No, we did not find. So we just need to find BC, and we already have the value of AB. So BC would be OC minus OB, and this would turn out to be -3, -2, 2, and the values are 0, 4, 1, and this would give us, the answer would be -3, -6, and 1. So that is BC, and AB was already known by this value that we found earlier. It was -2, -3, and 4. It was -4. Oh, that was AB, but we need to find BA. That means we can just take directly opposites of these. Opposite means if we want to find BA, that means this would be positive, this would be negative and negative. So we would say we already have AB. So if AB is known, so we can just reverse it. Reverse the signs of BA. BA would be, or we can just find it, but that's no need. We already have found, so we'll just reverse the signs. So now we can just plug in the formula that BA product rule or scalar rule of BC would turn out to be the magnitude of PA, with BC cos of C. So plugging in the values, still in the question, so just directly plugging in the values. I've shuffled the values, but that does not matter. We can just take the roots to get the magnitude. 2 square plus minus 3 square plus this, and the other one is this 6 square plus 1 square times of cos of ABC. So I'll just write simply that this would give us minus 6 plus 18 minus 4, and this would give us 929 root 46, and the angle 46. Angle AB of C, this would turn out to be 8 times this 1334 cos of ABC, and if you take cos inverse of this, or we can just take one more step, cos inverse of B, or we can say that B and then cos inverse, because we are finding B only. So we would have cos inverse of 8 over 1, 2, 3, 4, and the angle ABC would be in 0.3. You can just verify it from the answer. I have the marking scheme with me, that's why I wrote it like that. So this was part C, that completing the question 4.